Okay, so the next thing we're going to talk about are logarithms. A quick reminder before we start talking about logarithms that in the last set of notes we talked about exponential functions. The domain of an exponential is all real numbers, range is the positives, the intercept is at 0, 1, and it has an asymptote at y equals 0. An exponential function is when we have an x in a variable. These are our general shapes. If a is greater than 1, if a is in between 0 and 1. And then in the set of notes before that one, we talked about inverse functions. And inverse functions are functions that undo one another. For every xy on f of x, there is a yx on its inverse. The domain of f is the range of the inverse, and the range of f is the domain of the inverse. Okay, so we talked about solving these exponential equations last time, so we're going to try to get bases of the same. 8, 4, and 16 can all be written in base 2, so this would be 2 to the 3 to the x times 4 to the 2 to the 2x equals, 2 to the 2 to the 2x equals 2 to the 4. So then 2 to the 3x times 2 to the 4x equals 2 to the 4. We said that when the bases are the same and you're multiplying, you keep the base and add the exponents. And then we also said that when the bases are the same, once you have one base on each side, you can get rid of the bases and set the exponents equal to one another. So 7x equals 4, x equals 4/7. Now, it's not always going to be possible to create same bases. So here I have a base of 2 on one side and a base of 3 on the other. There's no way to turn something base 2 into something base 3, and there's no way to turn something base 3 into something base 2. Instead of approximating, because that would be annoying, just know that we can't use the same strategy that we did over here to solve something like this. And so does an exponential function have an inverse? Well, remember we said that to determine whether or not something has an inverse, it needs to pass both the vertical and the horizontal line tests. And I would say yes, both of those graphs pass both the vertical and the horizontal line tests. Okay, so the inverse of an exponential is something called a logarithm. Now I know that you have probably heard of logs before, but for right now I'm going to pretend that you've never heard about logarithms before, and we're going to start at the top. So remember that since exponentials and logarithms are inverse of one another, there are certain things that I know. I know that if the domain of an exponential is all real numbers and the range of an exponential is the positives and the logarithms are its inverse, then that means the domain of a log is the positives and the range of a log are all real numbers. Now what that means is that since the domain of a log is only positives, we cannot take the log of a negative. Negative is not in the domain of a logarithm. Now, the other things that I know are that it would have an intercept at 1, 0, because the exponential has an intercept at 0, 1. I also know that it would have an asymptote of x equals 0, because the exponential has an asymptote at y equals 0. And then feel free to pause this as liberally as you need to write everything down. If you're not writing anything down either, that's fine. But this is the way a logarithm looks. It is y equals log with base b of x. That's how we read that. Log with base b of x. And since they're inverses, every logarithm can be rewritten as an exponential. So y equals log with base b of x is the same as saying b to the y equals x. That's how we convert those back and forth. Now, If you are copying along, keep that page handy because we're going to be coming back to it and copying a few more things down. But using that log with base b of x equals y is the same as b to the y equals x. I want to rewrite these. So u to the 5 equals 25 would be the same as log with base u of 25 equals 5. And then this would be the same as log with base b of t equals -3. This would be the same as log with base r of 5 equals 2.4. And then going the other way, this would be 3 to the 2 equals 9. This would be m to the 1/3 equals 8. And now here on letter C, we don't have a base written. So let's grab page 119 again and make a quick note for ourselves that if there is no base written, that it is the common log. So the common log is log with base 10, and if we don't write a base, then we mean the common log. So then there's an invisible 10 here. So then this would be 10 to the v equals u. Okay, so let's take a look at some graphs here. We graphed this one in the last set of notes. We know that its domain is all real numbers. Its range is the positives. Its intercept is at 0, 1. And its asymptote is at y equals 0. So we're going to graph y equals log base 2 of x, which is the inverse. Now, a few things. We should expect that the graph will look like this, but reflected over y equals x. And to put the log with base 2 in the calculator, you have to do one of two things. If you have a TI-83, your calculator only knows the common log. So you would have to put it in the calculator using something called the change of base formula. So log with base 2 of x is the same as the log of x divided by the log of 2. Let's grab page 119 again and write that down. Okay, the change of base formula tells us that if we have log with base b of x, we could rewrite that as the log of x divided by the log of b. Okay, so then if you have a TI-84, you can change the bases. You just have to press math and then scroll down until you find log base. See it right there? It's letter A. So I'm going to show you both ways. If you have a TI-83, then when you put this in the calculator, you're going to do the log of x divided by the log of 2, making sure that you close parentheses when the calculator opens them for you. Right, glare. How about that? Is that better? Now, if you have a TI-84, you could still do it that way. Obviously, I have a TI-84. I did it that way. Or you could do math and scroll down and then press enter, and it's going to give you the option to put in that base 2. Whatever's easier for you. Either way would work. If you have a TI-84, if you have a TI-83, you have to do it the first way, but notice the graph is the exact same. Okay, and so of this graph, the domain is the positives, the range is all real numbers, the intercept is at 1, 0, and the asymptote is at x equals 0. Okay, now I would like for you to pause this video and try this example. Okay, so again, I hope that you actually did pause the video and I hope that you actually did try it. But here we go. My drawings are not super awesome, but I hope that you get the general gist, and I hope that you graph them in your calculator anyway. So keep in mind that since logarithms and exponentials are inverses of one another, the x-intercept on the exponential becomes, the y-intercept on the exponential becomes the x-intercept on the log. The horizontal asymptote on the exponential becomes the vertical asymptote on the log. Domain becomes the range, range becomes the domain. Okay? Now, honestly, the next couple of examples are good, but they're a lot. And considering that we are in a little bit of a time crunch, I'm not 100% going to worry about them. So for this set of notes, the next important thing that we need to know is how to solve log equations. And I want you to know that if our semester had not been cut short, I definitely would have gone through all of those examples with you. You can get the answers. You can copy all of those down from the answer key that is up on More. So all you have to do to find that is go to the very first folder, the course information, and then there's a folder in there that says notes/workbook. And so if you just go into that, it's got the workbook answer key, and you can get the answers to all of those. But again, we're not going to see that on a test, and it's great information if we had all the time, but I am going to try to prioritize for us. You won't see questions like it on your homework. You won't see questions like it on your tests. So let's jump right up to page 126 and solve some log equations. So if you're looking at this and you're like, I don't know what's going on, usually the best thing to do is going to be to turn logarithms into exponentials and exponentials into logarithms. So for example, here, if I rewrite this as an exponential, it would be 2 to the 4 equals x, and we know that 2 to the 4 is 16. So that means x equals 16. And now for letter B, we certainly could get bases to be the same, but we've done that already, so let's turn this one into a log. As a log, this would be log with base 2 of 8 equals a. And then from there, I can use my calculator. Again, if I have a TI 83, I would have to do just this log button that's right here for me. Log of 8 divided by the log of 2. If I have a TI 84, I can press math and then scroll down. One more, to log base, and do log base 2 of 8. And either way, I'll get the same answer. So that means that a equals 3. Okay? So we'll do the same thing for letter C that we did for letter A. So this is a to the 4 equals 16. So just like if this had been a squared, we would do the square root. If this is a to the 4th, we do the 4th root. So a equals the 4th root of 16. To put the 4th root in the calculator, you're going to, if you have a TI-83, put the 4 in first, and then press math, and then scroll down to this x root. If you have a TI-84, you don't have to put the 4 in first, but if you have a TI-83, you have to put the 4 in first. So the 4th root of 16 is 2. And then for letter D, we're going to do log with base 3 of 1 over 27 equals y. So that would be the log of 1 over 27 divided by the log of 3, or log base 3 of 127. Either way, you should get y equals negative 3. So this one would be 7 to the 2 equals x minus 1. I don't know why I put that in parentheses. 49 equals x minus 1, so x equals 50. Now, the only time that turning an exponential into a log isn't really going to work is if your base is where your variable is. So here, I'm just going to take both sides to the reciprocal of this. The reciprocal of 1/3 is 3. 1/3 times 3 is 1, so this is just 8. 2 to the 3rd is 8. So again, the exception to that, turn logs into exponentials and exponentials into logs, is when your variable is in your base. Okay, here I would say 2 to the 2x plus 1 equals 2 to the 2. Or you could have said log base 2 of 4 equals 2x plus 1. Either way, your next step is going to get you at 2x plus 1 equals 2. 2x equals 1. When I subtract the 1, x equals 1/2. And now let's just say that you didn't recognize that you could convert on letter H. Then we could have gone back to log base 2 of 1/2 equals x squared minus 2x. If you put this in the calculator, you should get -1. So then x squared minus 2x plus 1 equals 0. That's going to be x minus 1, x minus 1. So x equals 1. And then for this one, this would be log with base 3 of 10 equals x. So the log of 10 divided by the log of 3, 2.096. Makes sense too because I'm asking 3 to the x equals 10, and since 3 to the 2 is 9, I would expect 3 to something just over 2 to be 10, since 10 is just over 9. Now, we skipped around a little bit, so we didn't talk about E and its relationship to logs. So if we could jump back to page 119 where I was keeping my notes. Let's find it together. Where did I put you? Here we go. The last piece on here is to let you know that log with base E is the natural log. So log with base E of x is the same as saying the natural log of x. Now, I know that I said natural log and it's listed as ln. That's because when this was first discovered, it was back in the days of people speaking Latin, and in Latin, much like in other Romance languages like Spanish or Italian, they use the modifier before the thing that it's modifying, so this was called log natural. Anyway, e to the x and ln are inverses, and we can also use change of base with ln, just like we use it with common log. Now, what that means is that if I turn this into a log, it would be log with base e of 26 equals x plus 1. But log with base e is just ln. So this would be the ln of 26 equals x plus 1. And that I can put in the calculator. See the ln button? No, you don't, because I can't get both it and the glare. See the ln button right here? ln of 26, 3.258 minus 1, 2.258. Okay, so for us, for right now, those middle pages we're not going to worry about. Just make sure that you have this page 119 with all of your notes on it, because that's going to be everything really that you're going to need. And then we're going to be solving a lot of log equations. That's going to be what you're going to see the most of on your test. So make sure that you're comfortable with these, because our next set of notes we're going to get into a little bit deeper into solving log equations and properties of logs. All right, we're getting so close. I hope that you guys are still hanging in with me. I know that this is not an ideal way to learn, but please make sure if you're watching these and you have any suggestions or any questions, please reach out, okay? Thanks, guys.